Find the tangent line to f of x equals x cubed plus 2x minus 1 at x equals 1. Still bent out of shape from Monday? Well, you better bend yourself into shape. Better fix that real quick. What would your generation say? I'm not finna fail this class. Is that what you people would say? Finna? It's ridiculous. I mean, even if I'm wrong, I hope I am wrong because I don't want to be correct on such ridiculous things. Okay, so let's compute this tangent line. So how do we compute the tangent line? So, Dr. G, I don't know how to compute a tangent line. Yes, you do, because I told you. Right here. So there are two definitions, right? They're important. First, I need to know, so tangent line is right here. So this thing defines the tangent line. And there are two pieces, right? The point it passes through and the slope. Okay, but what is this slope? What is this thing f prime of a? Well, I look back at the previous definition, and that's this. So to find this tangent line, what we're going to do is getting the point will be very easy, right? Because that comes from the original function. Notice it's f of a. The y value of that point is from the original function f. But the slope of the tangent line comes from this derivative f prime, and that's this whole limiting thing, this whole limit. So let's now compute that. Okay. So just to make it clear, so in that language from before, a is equal to 1. Okay. So what is the point of our tangent line? The point that the tangent line must pass through is a f of a. So in this case, that is the point 1, 2. Swarnima, how did I get this 2? How did I get that number 2?
You put it into the equation.
That's right. I just plugged in x equals 1 into f, right? Because remember, the original function gives me points on the graph. Now let's get the slope. So according to my definition, the slope of this tangent line is f prime of 1. Now, all of you have taken calculus before. So a is x. Well, in this case, yes, sometimes we say the tangent line at x equals 1. Sometimes we'll say a equals 1. Before we had to use a because we needed a different variable from x. That's all. It's a dummy variable. So it doesn't matter really what we call it, as long as it's clear. So in this case, we're calling it x. So now, for all those who've taken calculus before, I don't want to see you right now for this problem saying, oh, I'm just going to take my derivative and then plug in x equals 1, easy. I mean, how did you get those limits? I mean, how did you get those shortcuts, right? You had to use the limit at some point, right? You cannot use the shortcuts until you figure out why they're true. So the only thing we have right now is I have to use the definition of derivative right now because that's the only thing I have. So the definition of derivative tells me that f prime of 1 is f of 1 plus h minus f of 1 all over h. Excuse me, and then I take the limit as h approaches 0. That's the only thing I have going for us right now. Okay, so let's compute this limit. So f of 1 plus h is 1 plus h cubed plus 2 times 1 plus h minus 1. Then f of 1 is 2, so minus 2. Right, so this thing, f of 1 plus h, is this whole thing. And f of 1 is 2. And the whole thing is obviously over h. Now, all derivatives have this property where if you plug in h equals 0, you're always going to get 0 over 0. Right? The difference quotient has that property. So these limits that are never going to be the easiest thing to do. There's always going to be some algebra, and this is why we spend so much time on limits, right? Because derivatives are just limits. So how do I go about computing this limit, Rachel? Matza? Rachel? She's like rubbing her eyes. She's like, what? Rachel? Did he say Rachel? Do you want to pass the baton? If you're not sure, you could say, I'm not sure. I'm passing the baton to. If you're talking, you're muted though. You're gonna pass. Now, who you want to pass it to? You get to choose, Rachel. You get to be the mean one, like Dr. G. Who are you gonna pass it to? Uh-oh. Students never want to pass it. They always say, "I want to pass it." I'm not. It's fine if people are not sure. I want to pass this question to someone else, but they're always too afraid to pick who to pass it to. They leave that to me. All right, Sarah. It's okay, Rachel. I'm not going to make you pick on your fellow classmates. Sarah, what do you think? How would I go about computing this limit?
See, I took calculus, but I don't remember being good at this. So.
But we did just do this for the first exam. See this, if I asked you compute this limit, I didn't tell you how to do with the derivative, but I asked you compute this limit. This goes for everyone, I'm not just talking to Sarah. If I ask you to compute this limit, and I realize the screen is frozen. Compute this limit, it could have been on the first exam. Jacqueline said, or go ahead, Sarah.
Oh, I was gonna say I would probably distribute things or try to multiply by the reciprocal of like h and get it all on like one.
Well, it is already one fraction, but you are right with the distribute, right? In other words, I'm going to expand out the cube and then try to cancel. Yeah, expand and distribute. Okay. There was a question, Nishika, you said, I'm confused how you got a equals 1. The question told us, find the tangent line at x equals 1. It told us. Okay, so let's expand out this cube, and you all know how to do cubes, right? So we get 1 plus 3h squared plus h cubed plus 2 plus 2h minus 1. That's okay. Sometimes we read a question so fast we don't even see half of it. That happens to me all the time. I expect the question to say something, so I just don't read the second part. All right, so let's see what cancels out. So hopefully my constants have canceled out. So 1 and negative 1. Did I? Oh, I forgot to write the minus 2. As I can say, the 2 should cancel out as well. I forgot to rewrite the minus 2 at the end. So minus 1, and then there should be that minus 2. Okay, so let's see. So we get here, the 1s cancel out and the 2s cancel out. That's good. So I'm left with, let's see, I'm left with 5h plus 3h squared plus h cubed all over h. And now there's a common factor of h. All right. Let me factor it out to actually explicitly show that. And then I can cancel. So I'm left with 5 plus 3h plus h squared. And now I'm in business. Now I can actually compute the limit, right? We know that as soon as that h gets canceled out, I can now substitute h equals 0. And when I substitute this, I get 5 plus 0 plus 0. So I get 5. Now, all that work, let's not forget what we did, right? What did we actually do here? We calculated, first of all, the point that the tangent line has to pass through, and then we calculated the slope, right? So now forgetting about the calculus momentarily, I need to now find the equation of a line whose slope is 5 and which passes through the point 1, 2. Okay, so that's y equals 2 plus 5 times x minus 1. And we're all done. Right? Because that actually did say to find the tangent line, not just the slope.